Hey guys, today we'll be learning about edges, vertices, and faces. My name is Prithvi Patel, and I like spending my free time playing soccer. My favorite snack is pita chips and hummus, and I'm working with...
Hello guys, my name is Parth Patel and I'm working with Prithvi on this curriculum, and I love to play Ultimate Frisbee and I used to play the Steel Pants. So essentially in this lesson, students will learn how to determine the different faces, edges, and vertices of different 3D shapes using various ways such as nets and the actual 3D model. And the skills that will be acquired are the students will learn how to create the nets of 3D shapes. They'll learn the difference between faces, edges, and vertices, and they'll learn how to identify all three aspects of a shape using a 3D model. This curriculum is recommended for students between 3rd and 5th grade. So some important terms to keep in mind are edges. They're line segments on the boundary of a shape that joins one vertex to another. Vertices are the corner of a shape where multiple boundaries meet. Faces are the flat surface of a shape that makes up most of the shape. The net is used to show a 3D shape in a flat model. And 3D shapes, they're solid objects that have all three different dimensions that are length, height, and width. Now we'll move on to nets. All throughout the slide you can see different types of nets. If you look at the top left corner and the bottom right corner, this is how a net turns into an actual 3D model. So first we'll start off with some more basic nets that include four-sided shapes, such as a rectangle and a square. So at the top is a rectangular prism, and at the bottom is a cube. The top one is made with both rectangles and smaller four-sided shapes, while the bottom is just made completely of squares. And when these nets are put together and folded, they create the actual 3D shape. And now we'll move on to more complex nets. These include circles. So the top one is the net of a cylinder, which includes two circles to cover the bottom and the top of the shape, while the bottom one is of a cone, which contains only one circle to cover the top. Now we'll move on to shapes that are even more complex than the previous slides, such as the pyramid, which includes both squares and triangles, and the dodecahedron, which contains a bunch of pentagons. And the dodecahedron is actually what we think of as a soccer ball. So this animation here, I'll let it play out, but what it essentially shows is that it shows how a net, like a basic net of that of a cube, just how it folds and turns into an actual 3D model. As you can see, all the sides just fold and create this one 3D shape, and this is how we look at the different edges, vertices, and faces that Prithvi will now talk about.
Now that Parth has talked about various nets, we can now talk about the components that it has. In the next couple of slides, we'll be using the net and 3D diagram of a cube to talk about the faces, edges, and vertices. First off, we have the faces. The faces are the flat surfaces of 3D shape as shown below by the arrows, and there are a total of 6 faces on a cube. Next, we have the vertex. Each corner on a 3D shape or model represents a vertex, and as shown, there are a total of 8 vertices on a cube. Finally, we have edges. Edges are the lines in between two vertices on a 3D model or a diagram using a net, and a cube has a total of 12 edges. Now we'll be moving on to Euler's formula, which will be used if you have a missing, if you don't know how many vertices or edges or uh, faces there are. The formula for that you would be using is v plus f minus e equals 2, which is essentially vertices plus faces minus edges equals 2. And like I said before, you'd only use this if you don't know how many vertices or edges or faces there are, assuming that you have two of the other components. So a little example to show you how it works is on this cube. There are 8 vertices, 12 edges, and 6 faces. And using the formula, since there are 8 vertices, you do 8 plus the 6 faces minus the 12 edges, and you'd see when you calculate that you would get 2. So how you'd use it is, if you need to calculate vertices, you'd first identify the number of faces, then count the number of edges, and finally, using the formula, you would calculate the number of vertices. And you'd use this for faces as well, except first you'd identify the number of edges, then count the vertices, and then use Euler's formula to count the number of faces. And finally, for calculating edges, you would first identify the number of faces, then count the number of vertices, and finally use Euler's formula to calculate the number of edges. Now we'll do it in practice. This shape has 12 vertices and 11 faces, but we don't know how many edges it has. So to calculate it, we would use this formula, which is f plus v minus e equals 2. So first, you would figure out that it has 12 vertices and 11 faces. So you do 12 plus 11 minus the edges equals 2. Then you move over the equation so that way e is by itself, and you get e equals 23 minus 2, and then finally you do 23 minus 2 to find out that there are 21 edges on an icosahedron. Now on your own practice. In this shape, there are 30 edges and 12 faces. You have to calculate the vertices. You can pause here and come back when you're done. Now after you finish that, you'd figure out that there are 20 vertices using Euler's formula, because after plugging in the 12 faces plus the vertices minus 30 edges, and then solving for v, you'd get 20. Now these are some links for more practice to identifying nets if you still need more help. And then these have links for with practice on edges, vertices, and faces.